Good afternoon to Ms. Ang. We from Group 43 would like to present our project for TCN6213 computer networks. We consist of three members in our group, myself, Yuendiran, we have Fang Yong and Justin Matthew. To begin our presentation, we would like to briefly explain on the project budget for this network setup. So project budget consists of three different segregations. Firstly is the network hardware and components. Consists of the main things we need for this network setup, such as the routers. Use Cisco routers 2911, Cisco Catalyst switches, servers for the ISP, DNS, web and file server, PCs for student, tutor and admin. So these are the four basic things need. As you can see, there's quantity and price per quantity. We also set total cost for all the items. Apart from that, we need a firewall hardware, as consists of Fortinet, and we have a power backup or cables such as fiber optic cables, copper straight cables and Cat6 cable. To compile with that, we have patch panel and Ethernet wall sockets. And other items that we need are cable ties, cable organizers, cooling systems, spare parts, electrical safety and fire suppression tools. So all the hardware and components almost cost up to RM 400,000. As for the software and configurations, we need network operating system licenses, Windows Server Standard license, and firewall activation software. As for the network monitoring tools are free. SolarWinds has been used, and we have switch and router configuration services as well. And one of the main things that is internet subscriptions or the ISP subscription of TMNet 1 GB per second has a monthly price of 249, and we have totally up for a yearly cost, and the subtotal for the network software and configurations comes up to 17,000 ringgit with a yearly fee of up to 3,000. And the final segregation is engineer and labor. For the network engineer and labor, we needed three different expertise, such as the senior network engineer, network architect, or the IT network assistant. So their job scope are such as network design and installation, configuration and testing, relocate, assemble PC servers as a manpower and assistance. So network engineer and labor costs approximately up to 22,000 ringgit. So the total cost for this project, or the total budget for this project, is up to 441,000 ringgit with a yearly cost of 2,988 ringgit for the ISP subscription. So as you see roughly how much the project budget will cost, we will now head to the demonstration of the logical and physical topology.
Good morning to Madam. My name is Fang. So as you can see, this is our interim design. This is for the logical part. We have used three main router, which is the first one is the main router, then the internal router and the lab router, which is connected to these two lab. The internal router is connected to the classroom and the admin, and the main router is connected to the internet room, system administration server room, and student wireless network. And here you can see this is our physical design. So I'll be talking about how we can transfer the FTP file and receive and everything. So first we have to find our FTP IP address. Copy this FTP IP address. After copying the FTP address, go to the lab PC, open any lab PC, and then to check if it's working, press ping and then paste the so this shows that it's being received and is working. So to connect to the FTP server, just press FTP, then paste this, and then admin 123, type password. So now you're connected to the FTP server. So at another lab, just choose another PC. So for this one, we should create a file that we want to send over. So we'll be testing p123, then save. Yes. Oh. TXT. So here, connect to the FTP server 2. So here you need to put in the file that you want to put into FTP. So here it shows that it's transferring the file. So once it's completed, it will say that it's completed. To check if it's in the file, you can see here testing ftp123.txt. So to download it, go back to the previous lab PC. And here, you will get the file that you want, which is testing. So this shows that transfer is complete. That means it's already in this computer. Thank you.
We will start with the dynamic host configuration protocol, also known as DHCP, processed within our network. On the router, we have configured DHCP to dynamically assign IP addresses to devices on the network. Now let's see how a PC obtains its IP address dynamically. So I will select a lab PC1 instructor and I'll show the IP configuration. As you can see, it is set into automatic and the IP address has been dynamically assigned to it. So you can repeat this process with any device in the system. Let's pick another PC. And I go to IP configuration and it's all set in automatic and the IP address is dynamically assigned to it. This shows the dynamic host configuration protocol works fine, and it also has the IPv6 request is successful. So you can repeat the process with any other devices on the network and you'll still see how the DHCP has automatically assigned the IP addresses dynamically. Next, I'll show a successful ICMP. ICMP is known as Internet Control Message Protocol. It is a network layer protocol in Internet Protocol, IP, providing methods for hosts and network devices to send error messages or operational information regarding the network conditions. ICMP is commonly used for diagnostic purposes, including troubleshooting networks and checking the reachability of hosts in a network using tools like ping command. So now we will see how ping command works in order to show a successful ICMP. So first we have to select a host. In this case we'll choose a lab PC2 instructor, lab 2's PC instructor, and we'll go to the command prompt. So here we have to type ping followed by the destination IP address. So in this case, let's say I pick lab PC1, lab 2's PC1, and I see the IP configuration here, choose the IP address. So in this case you can't copy paste, so I'll manually type it. So once you have typed the destination IP address from the host PC, you click enter and then here you receive the network conditions and operational information for the host. So as you can see, the host has connected to the destination device and you have information such as how many packets sent, received, lost, and its round trip times in milliseconds. So you can repeat this process using any host and any PC, any destination address, and it works the same. There's a simpler way you can show a successful ICMP is via this envelope icon. Once you select this envelope icon, you choose a host, and then you can select any network destination device. So I pick this. So as the ICMP is successful, you can see below here where it shows the operational information, and it shows successful ICMP. So the same thing we did with the tools and the ping commands. We ping one host to its device, and also you get the operational information, or you can choose the envelope icon and do this. And this is how you show a successful ICMP. So that's all from me, and I'll pass it to my next crewmate on the following demonstration. Thank you.
Hello, madam. Good evening. So my name is Justin. So today I'll be presenting my part for the presentation. So firstly, today I'm presenting two parts. For first thing is showing DNS and web server works, and the second one is showing ACL works. So firstly, let me show you the packet tracer. So this is the packet tracer map, and now let me show you the DNS server. So as you can see here, I've already typed in earlier http mmu.edu.my, and it is able to show the page correctly. And now let me show you the web server. And from here also, madam, you can see it's also showing the correct thing.